Hi, my name is Shikhar, and I'll be talking about threat modeling for OpenSearch, specifically of if you have your own OpenSearch deployment, what you need to think about in terms of security and some basic threat modeling techniques that you could leverage when you when you host your own OpenSearch deployment. In brief about me, I'm a senior software engineer at Amazon. I work on the OpenSearch security team. I've been part of the same team for nearly 4 years now. Uh, In brief, what we're going to cover today is a quick refresher on OpenSearch architecture, because it's really important to understand what you want to protect in order to protect it, right? And we'll explore some basic framework for threat modeling, something known as STRIDE framework. It's a well-known framework developed by engineers at Microsoft. And I'll show you some common security threats that we see day to day and how the patterns emerge even in the new age of AI. And I'll also talk about what OpenSearch offers, how you can protect your deployments using OpenSearch security plugin. We'll also talk about some best practices and network security as well. Before we jump into what we're protecting our service, we also need to ensure why this matters, right? OpenSearch generally ends up containing sensitive business data. That could be your logs, that could be vectors, information about your vectors, or customer information, or even just business analytics data, right? According to IBM's latest report, companies generally, or data breaches generally tend to be around $5 million of losses. And it's not just about the money. If you are a customer who cares about compliance, HIPAA and GDPR generally fine you if you breach any compliance. And more than that, personally I feel that security is not just there to give you more features to your products. It's also to protect the existing revenue that you have. For example, if you can see on the screen, $10 billion was the estimated cost of total data breaches last year, right? So that's a hefty amount. But it's not all sad and gloomy. There is definitely ways to protect your service, and that's what we are going to talk about. So before we start, what is threat modeling, right? So threat modeling in simplest of terms is thinking like an attacker so that you can defend your service like a professional, right? If you don't think of what could go wrong, it would be not easy to protect the service that you want, right? So instead of waiting for security incidents to happen to you, you can proactively think about what could go wrong in your deployment and then use it to mitigate before it actually even happens. It also helps you make better architectural decisions. For example, how does data flow look like? Where do you store your data? How do you host your service? Do you go for a self-hosted deployment? Do you go on-premise? Do you go on cloud? Do you use a cloud-native solution? Do you a managed offering, right? Like depending on your expertise, depending upon your compliance regulatory requirements, you could make a better architectural choice. And in my experience, I've seen that it's easier to fix a security flaw in design rather than in production. I would say it's like 100 times expensive to fix a problem in production with respect to security, because by the time you realize there's a problem, it's already global, right? So how do we create a threat model? As talking about STRIDE earlier, so STRIDE is a well-known framework. It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. I'll relate each of these on what it means in terms for OpenSearch, right? For spoofing, simplest terms, it could mean an attacker posing or looking like a legitimate user. They could be using stolen credentials or default credentials. For example, using admin as your default password, right? It could be bad for your system. Tampering means modifying data without authorization. So if you have a weak configuration, an attacker changing log entries or changing query results without you knowing it could heavily impact your application. Repudiation is a form of attack that could happen internally. For example, a user accidentally deleted a production index, but then claiming that they did not do it. So without audit logs or audit trail, you are lost in the sea where did the index or where did all your data go. Information disclosure is exposure, unauthorized exposure to data. For example, you create an OpenSearch installation but leave it authentication and authorization less open to the internet. I know when I say it out loud, it sounds stupid. Why would somebody do that? But believe me, I've seen people having open default configurations and starting to use them in production, leaving them open to the internet. Denial of service is where as in simplest of terms, I, as an attacker, could start polluting your cluster with a lot of requests, bombarding your cluster with requests. requests are nothing but OpenSearch queries in this case. And when each query, as you know, takes some CPU memory, it's an intensive operation. So I'm performing a denial of service against, so that all your legitimate users can now not use OpenSearch. So let's say if you have a search application like a search bar or something on your website, it's no longer accessible because somebody is performing a denial of service attack. Elevation privileges is gaining unnecessary permissions. For example, let's consider the widest incident that happened in history in a couple of years ago was the Log4j, right? Like it was an elevation of privilege attack where if you're using a Log4j jar in your application, I could gain a reverse shell access to your system. You definitely don't want your users or even evil actors to get host access where you're running your OpenSearch system or any other system for that matter, right? So now that we have a basic understanding, let's take a quick refresher on what OpenSearch architecture generally looks like and how do we protect it, right? So an OpenSearch general, a very high level overview, like 10,000, 20,000 feet overview of the architecture. You have different applications, also OpenSearch dashboards connecting to your cluster. Your cluster could be front-end with something like a general load balancer, and OpenSearch by default runs on port 9200, right? And then this connects to coordinating nodes, manage routing of requests. You also have cluster manager nodes that manage the cluster state. And then you have data nodes that host your actual data, and you could also use ingest nodes or ML nodes for different use cases, right? Each node by default has two ports that it can communicate on. One is the port 9200, which is your REST layer, your HTTP requests. Another is your transport layer, port 9300. Both, while OpenSearch offers this great distributed architecture and it helps us build resiliency and availability, one of the challenges it brings is the multiple surface points. For example, on each node now you have to protect a port 9200, you also have to protect a port 9300, right? So, and going to the key assets of our system, definitely indices and documents are the key assets. This is the most critical data that you want to protect. Similarly, cluster metadata, while it may or may not contain confidential information, it does contain state mappings and things like cluster settings, which may be critical for your system. Now, apart from data, there's also user credentials that you would like to protect, because leaked credentials could definitely harm your system, right? Entry points or access points, as we can call them, are different ways of entry or surface areas where somebody can enter into your system. For example, REST API endpoints, transport layer that we just spoke about. And let's not forget about dashboards. Dashboards is a critical entry point into your system, because as a user of OpenSearch, you would definitely go and configure dashboards, get some nice visualizations out of top of it. But we pay less attention to dashboards because we always think it's just visual data, but dashboards also get full access to your cluster. Even though if you might be running, let's say, your OpenSearch in a private network, we end up opening up dashboard to a more wider access because you want to monitor it on your TV screens or whatever, if you have a live traffic or live event, right? So it's definitely a very easy entry point into the system and one of the critical ones to protect. Similarly, if you are running a custom deployment with custom plugins installed, so each plugin to an OpenSearch is like an add-on to a browser. It could steal all your data. It could get full access to your cluster and perform malicious actions. So think of it as if you're running a Python application, Python dependency. A vulnerability in the Python dependency can eventually harm your application. So even if you're running custom plugins, we need to ensure that you trust the code and you keep updating whenever there is a security dependency, right? Now that we have an understanding of what we want to protect and how we should go about it, right? So we can look at what a general, we'll go deeper into what an architecture looks like in an enterprise world or a real world. And before that, let's see about trust boundaries, right? Like, so if now that we know you have different levels of trust, like you have different personas in the system. For example, an admin is a person who sets up your OpenSearch cluster. The admin definitely has more privileges than a end user of your application, like a website or a mobile app or anything that you build. Similarly, there will be some different layers, or your application has a read-write access versus your user has only read access, but admin has a full read, write, delete, all kind of access, right? So identifying trust boundaries is important. Whom you can trust, who can access what, where does the trust boundary change? These are all critical questions to answer. You can think of trust boundaries as security controls that need to be enforced. And these are like, in a real world, this would be like country borders that you need to protect and be very careful about on how data flows or travels between these borders. For example, if we look at this diagram, right? Like to the most left is the most red or the untrusted zone where your end users lie. So you don't know about them. You have no idea who is accessing your cluster. And this is just anybody in the wild, anybody on the internet who can come and access your application, right? This could be potential bad actors. It could also be genuine active users. So you would generally filter this out, or you will have a perimeter network or a border network on your application, where you will run a firewall where you intercept all the traffic that is incoming and ensure that only allowed traffic or good traffic gets to your load balancer. So once the traffic reaches your load balancer, you'll route it to your application where your business logic runs. And let's say your business logic now relies on an OpenSearch cluster to get some data out of it to perform search. So if you see here, I want to keep my OpenSearch in the most trusted network or the most private zone because that's where my data is, right? And similarly, if I need more access to the OpenSearch cluster as an admin, the persona we spoke about earlier as an admin persona, they should have access to the system using a Bastion host or a jump host. Missing or weak controls whenever the data flows across boundaries is what leads to most of these security threats or most common problems. So we can look at some common threats now, right? So a few of the common threats that we see, these are also listed like in OWASP top 10. If you do an OWASP top 10 security threats, these are the general buckets where most of the attacks fall into. For example, we spoke a bit about unauthorized data access, right? Like this is one of the biggest problems if you're using weak passwords. We spoke about using admin or using exposing your OpenSearch to a public internet without any auth on it, right? Man in the middle, this is a attack where, let's say you're transferring an amount of data. We just saw that you have cluster manager nodes, multiple data nodes due to the distributed architecture, but you're not using TLS or HTTPS or the way whenever you're logging into a website, you see HTTPS symbol on the browser, right? So it runs like secure transport channel TLS. So if you're not using TLS for communication, that means anybody who has access to the network has access to all your data. Injection attacks are, we are speaking about an application where you have a search bar or you have a search system in your application, and let's say somebody comes in and types show me cars. You could use this string, and let's say you send this raw string as is to your OpenSearch. It's a good string, so happily OpenSearch will search and return all the documents or everything that matches to cars. But let's say a bad actor uses the same input box and crafts a very lengthy Python script which actually opens up a reverse port, and you just, without sanitization, without input validation, you run it across your cluster, and OpenSearch understands this query now, and if it opens up a reverse tunnel to the attacker, that's a bad thing, right? So injection attacks, this also is a very old style of attack, like a SQL injection, and we also see these attacks emerging now with prompt injection, right? So prompt injection is similar, where if you are hosting a Gen AI bot or some bot and somebody comes and crafts a malicious prompt where it undermines the system or asks the system to act in a different way than it is supposed to be, it leads to an injection attack. Denial of service, I think we spoke briefly, where somebody is trying to fulfill or run out your cluster out of memory, out of space, whatever, right? Data loss or corruption, it might not always be malicious. It could also be something gone wrong, but it's important for your system to have backup strategies in place. So given that we now know some of the threats that you can land into when running an OpenSearch deployment, we can also talk about what OpenSearch offers you as customers of OpenSearch so that you can mitigate some of these threats out of the box, right? Introducing the OpenSearch Security plugin. So it's like your Swiss Army knife to all these tried threats, right? It mitigates, I would say, at least 5 to 6 top threats that we just saw, where because it's out of the box, it supports multiple features, right? For example, spoofing, tampering, these features we can mitigate easily if you configure the security plugin right. It offers different form of authentication. You could do basic auth, simple as username, password. You could do LDAP, SAML, OIDC. So any of these industry standards are available by default. You just need to configure them and start using them, right? On top of it, it supports something called as role-based access control. So you could do different personas we were speaking about, like your end user should have only read-only access. admin should have a security configuration access plus write access plus delete access because they are the admins of your system. Similarly, your application would need read access to read data, write access to update data, right? So you need something in some sense, a role-based access control, which security plugin offers. It also supports by TLS by configuration or by default on both transport and network or HTTP layer, and as well as the transport layer, so that you can configure TLS and ensure that there is no man in the middle sniffing your network and reading your plain text. So once you configure TLS, what that means is your sensitive business data is now being encrypted before it gets transmitted. So even if somebody is sniffing or somebody gets hold of that data, they cannot make sense of it anymore because it's now encrypted. OpenSearch Security plugin also performs audit logging. So any action that you take on a cluster once you enable audit logging is logged. Audit logs can be shipped to a different system. They can be written to a log file. They can also go into a different index of its own. So you can store these audit logs for as long as you like, and you can also analyze them to understand what users are performing on your system. And if you want to be an advanced user of the security plugin, right, some of the features it offers is attribute-based access control. What this allows you is, let's say you're hosting an OpenSearch cluster as a multi-tenant. So you have multiple different applications or multiple different clients accessing the same system. You could segregate them based on attributes. You can say that people from my HR department can only read HR data. People from my services department can only read service data. IT department can only read IT data. So OpenSearch Security supports that by default. You could also do field level security. So for example, let's say I don't want end users to see credit card numbers that I have in my system, right? So it supports field level security where you could remove the credit card number as a field and the document would look like it never had a credit card field in it. Talking about encryption strategies, I think we spoke about all of this. The couple of things that I would like to add here is when you're running a TLS encryption that we just spoke about, it's also good to have a certificate per node. What this gives you is, let's say somebody is a rogue machine that is trying to join your cluster would not be able to join the cluster because it does not have the certificate that you want it to have, right? So the way HTTPS or TLS works is both the parties should be able to understand that I can trust. You can establish a chain of trust all towards your parent authority, and only after that it would be able to connect to the cluster and be the part of the same cluster that you have. Using perfect forward secrecy or is an advanced setting, or if you're aware about TLS, it allows you that even if, let's say, whenever you are using encryption, one of the most popular algorithms for encryption is RSA. RSA relies on a public key and a private key. Let's say your private key gets leaked, you can no longer rely on that private key because all your sessions are lost. Even not just your current sessions, even if somebody gets hold of your previous sessions, they can decrypt those sessions. But let's say if you use something like a perfect forward secrecy, what it does is each session has its own new cipher. So even if your current session were to get compromised, it would not compromise the security of all your previous sessions. This is general TLS, which is by default supported. There's some additional features, for example, field masking, where in field level security, where you could remove the fields completely. Field masking also allows anonymization of fields. So let's say if you have PAN card data or Aadhaar card data indexed into a document and you want obfuscated view of these fields, you could also return. So this is useful when you want your users to know that these fields exist, but you cannot see the actual values of these fields. We spoke about what security plugin can do, but it can help with a lot of these things, but it cannot help with some of the features. We don't need to rely on it alone. Defense in depth is your friend, and network defense or network security, protecting your application by using the different trust zones that we set up earlier, ensures that even if someone is able to cross some boundaries, or let's say security is also a product, right? OpenSearch Security, it has a vulnerability, but if you still isolate your product in terms of network zones or the trust zones that we spoke about, it does not, it ensures that your entire application is not compromised. For example, let's say this is the somewhat similar diagram that we saw earlier, So somebody is able to compromise this, or there is a vulnerability in security plugin. That means maybe role-based access control is no longer working, or you have a misconfiguration where a user who should have a read access now gets accidental read plus write access. They can only perform so and so operations when they are in your private network. They cannot, from anybody out on the internet, will not be able to directly access your cluster, and hence it is still protected. So in a way, by establishing different trust zones, you have ensured that your application is not, or your OpenSearch cluster specifically, is not directly available on the internet for you attackers to attack. So we spoke about network, we spoke about specific things to OpenSearch, but as a general guidance, I would also like to add something on what you could do in your application to ensure that it also helps you as a different defense layer, right? So we spoke about you accepting a user input where somebody could write a Python script which is malicious and sending it to your application, and then your application misbehaves. So an easiest way of doing that is input validation. For example, if you're expecting a 100-character query, or only a 10-character string in the input, you should ensure that if somebody sends a 10,000 long character, you just fail the request and alert yourselves, right? Somebody's trying something malicious on the system. At an application level, like OpenSearch has a very powerful query engine, we all know that, but same query engine can be used to exploit the denial of service attack in the simplest of forms, where I could write a very expensive query, and you use that query as a substitute to query OpenSearch directly or indirectly, right? So using parameterized queries, by that what I mean to say is you only substitute specific parts from a user input and not accept the entire user input as a direct query to your system. By parameterizing the query, you ensure that you are only running selective filters or selective queries that you want from OpenSearch, which are very limited limited in are not IO intensive per se. As a simplest of examples, let's say if somebody is accepting a user input and I write a wildcard like a star, and you see that, okay, I'll use this, and thinking of database terms or a SQL query terms, you run a select star from a table. That we all know it runs a complete scan and it's just a waste of memory, right? But if I could do parameterized query where I say, no, you tell me what you're exactly looking for, and I just use that parameter as a substitution, when I'm performing a query to OpenSearch, it will help protect OpenSearch better. Now, coming to the last layer of defense that you could use is OpenSearch also supports a query level allow listing or deny listing, where you can say these queries are never allowed on my system, right? It also supports something called as circuit breaker. Circuit breaker, by definition of it, means that when, let's say, if a CPU utilization or memory utilization of your system crosses a predefined threshold, it will trip instead of going down, instead of the server dying, it will trip the query and it will short circuit it. Now, let's say you have completed all the security setup. Are you done? Surprisingly, or I would say no, because security is kind of a continuous exercise. Even though you have set it up, you need to continuously monitor and have a proper incident response plan, right? So how do you monitor what's happening on your cluster? We spoke about audit logs. What do you do with audit logs? You perform anomaly detection on them. You can see if, let's say, somebody starts brute forcing attack or starts using wrong username passwords again and again, or a malicious IP is trying to create a denial of service attack to your cluster. Audit logs are your friend, and you can start analyzing them to gain insights into what's happening, and then use them later as a mitigation, or start proactive mitigation versus somebody reaching out to you and saying, oh, your cluster is down, or I'm not able to access your application, right? So having a proper incident response plan, predefined runbooks, like, okay, let's say if you get a midnight call saying, hey, something's wrong and the cluster is no longer accessible. So you look right, left, right, center, you look into performance metrics, you see, okay, there is a big spike in request count. So was it a genuine spike? Was it a malicious user? This is where you start running through your runbook, but having a predefined runbook saying, okay, if the error response has been because of a circuit breaker, okay, let's look at what triggered the circuit breaker. Maybe it was a DOS attack, right? So you could use that information, then you could look at, okay, I'm getting a DOS attack from 1.1.1.1 and 2.2.2.2. So you use the network zones that we created earlier and firewall against these IPs, saying, no, these IPs no longer have access to my system. That was a very plain and simple example. Real world scenarios kind of tend to be more notorious, but you use these systems and the same mechanisms apply whenever you see a wider range of attacks from a wider range of IPs. So this is a summary of whatever we discussed today, like a best practices checklist to start off with. And a couple of things that I have added to this slide specifically are follow security updates. For example, if OpenSearch or security or any other component is releasing a new security update, it's good to always try and understand what that update means for your system, but always ensure that you update, right? Penetration testing is another interesting area. So let's say you have now designed this new application, you have all these network zones, you have thought like a attacker and defended your entire system. But let somebody externally validate whether your defenses work, right? Me as a designer, I would think my application is perfect, but I would like to have that validated by somebody else. And that validation by somebody else is nothing but penetration testing, right? And lastly, user training and incident response plan. Once you have a mindset of security, you can also train all your fellow developers or or your teams to ensure that, okay, I need to concentrate on security. This is the incident response plan we create. You think about security, when you start thinking about designing of a new application. Similarly, learning from others' mistakes or some things that I have also personally seen some of these, as I was speaking about using default credentials or exposing your clusters to public internet. These are something that you should not do. Like we had a best practices checklist. This is the just opposite of that, right? That's about it. So the key takeaways that I would say is it's not an optional thing. It's essential, right? It's an ongoing process. And not just relying on one layer, but implementing defense in depth is the way to go about it. These are some of the getting started resources for OpenSearch security. And I'd like to conclude with that. Whenever you read about security in the news, you always think that this won't happen to me, or this happens always to some other companies. In my view, that other company might be you tomorrow, because everybody is just a misconfiguration or a weaker eye. Like when you give a weaker eye towards something where it could turn into a mishap. So before you turn yourselves into a headline, I would say we should practice security first. Right, that's all. Thanks. Any questions? Sorry. Yeah. Go ahead.
Talking about security by design, can you just give me an example?
Okay.
Can you just give us an example of security by design which you have implemented at your workplace, Amazon?
Yeah. So, see, Amazon is very specific because it starts with security, but I would like to give a generic example. So when, for example, working on open source, right? Like when you're working on open source, you just create a GitHub issue, you start working on it. Maybe it's a bigger feature. You write a full RFC out of it saying that this is what I want to implement. But ingraining that okay, let's say I'm creating a new API for per se, right? So now this is a critical API for my system where it could give you access to, let's say, all the list of users. Let's consider a very simple example, right? So now that you know it gives a list of users, while designing itself, you'll need to think about things like who can access this API, how do I protect this API? Okay, I'm returning, let's say 10 users at a time, or maybe let's say you have a system, you just write an API, list users is a very simple API to write, right? But now your system has grown. You need to think about things like what happens if I have 10,000 users. So a fetch query on a 10,000 users could be a bad thing for you. So you start thinking about paginating the results, right? So things like that. And just we spoke about threat modeling, right? So thinking about all the angles where what could happen if the query runs wrong, or if the query runs for a longer period than you would expect it to. Do you short trip it? Do you ensure that the user does not always, or you implement things like API rate limiting, throttling, so that nobody can keep calling the API again and again if it's an expensive query, right? So things like that.
Thanks.
Okay, thanks.